Hey guys, so here's part 2 of the 3.5 notes. We're once again graphing radical functions. Okay, so let's talk about what happens when we have more than just the parent function. So to graph y equals a square root of x minus h plus k, or y equals a cube root of x minus h plus k, we're going to follow these steps. We will first sketch the graph of the y equals either a square root of x or y equals a cube root of x, and then shift the graph h units horizontally and k units vertically. So remember, when we talked about transformations, when we have h, so we have x minus h, that means we are going to move to the right h units. If we have x plus h, remember that means we move to the left h units. So remember, we did talk about transformations when we did absolute value. We talked about with quadratics in that vertex form, and now once again we're seeing the h and k. So this followed through a lot of different types of functions. Okay, then let's talk about our k. So we have a positive k, that means we move up k units. And if we have a negative k, that means we move down. Now the a value, okay, remember I talked about two things with the a value. A can tell us if we have a reflection. So we have a negative a, that means there's going to be a reflection. Okay? And that's going to be over the x-axis. And when we have values that are smaller and bigger, that's when we talk about a vertical stretch and shrink. So remember, we take the absolute value of a, and it's greater than 1. That means it's going to be a vertical stretch, because you're stretching upwards. That's why it's called vertical. Now, if we have our absolute value is less than 1, and it's going to be in between 0, that means that was a vertical shrink. Okay. So that means our graph is becoming wider. So those are some things that, remember, we talked about whenever we did a lot of vertex forms. Okay? So make sure you get that written down. It's just good to know, because whenever we kind of look at it, we can look at the graph and be like, is this the correct graph? Okay, let's go ahead and we're going to do a few examples here. Okay, let's look here. We're going to graph this function and then state the domain and range. So we have y equals negative 3 cube root of x. Now notice here we don't have h and k, so we really don't need to translate anything. We're really just going to graph this, and that's it, okay? So whenever we're doing this, our first thing is we do need to do our xy table. Now, before we do the points, let's kind of just ask ourselves so we can kind of keep working on transformations. Well, if we see this negative here, notice that we are going to have a reflection. And if we take the absolute value of negative 3, that is greater than 1, so that means we are going to have a vertical stretch. Okay, so that's just something, and we can definitely see that looks like what happens. Now, even though we have that negative 3, we are still going to use the same 5 points as we used for the parent cube root function, okay? So anytime you have a cube root, you'll always use the same 5 points. And then when we get to the square root, you will always use the same 4 points there. So the 5 points we used are negative 8, negative 1, 0, 1, and 8. Now the thing is, though our x values stay the same, the y values will change because we have that negative 3. So we have negative 3 cube root of negative 8. That gives us -2 times -3, which gives us 6. Then I have -3 cube root of -1. Well, cube root of -1 is -1. And we multiply that by -3 to give us 3. 0, you always just get 0 whenever you're multiplying or dividing. Then we have -3 cube root of 1. That's going to give us -3. And then -3 cube root of 8 will give us -6. So notice we still get the same numbers here. It's just the sign switch. So that's definitely where you can tell if you're doing something correctly with the cube root functions, if you're getting the same number and the signs are just switching. Okay, now let's go ahead. We're going to plot these points. So we're at -8 and then up 6. And then -1, up 1, 2, 3. Then we have 0, 0. And then we have 1, -3. And then 8. There we go. And so, did I do that? Yeah. There we go. And you can tell this looks vastly different than our, when we did our parent function, because that was a little bit lower, right, and down more towards our x-axis. This is a little bit up. So this is what we really call as our vertical stretch here, okay? Okay, now last thing is we do need to state the domain and range, just like we've done before. Now, the good thing is with our cube root functions, no matter if you stretch it, shrink it, reflect it, if you translate or anything, the domain and range will stay the same for every cube root function. Because notice we will hit all of the x values and hit all of the y values. Okay, and notice this is a reflection because remember the original went the other way. So we did do this correctly, so that's good. So with every cube root function, domain and range will always be -infinity to +infinity. So I would write that down because it's a little bit easier to remember that. And the reason it's always -infinity to +infinity for domain and range, if we do the inverse, which is x cubed, of course, x cubed is always -infinity to +infinity for domain and range. Okay, let's go ahead. We're going to do the next one. So make sure you got all of this down. So if you need to pause the video to write it down, please make sure you do so. Okay, let's try this. Now we do have our h and k, and we have a square root this time. So remember when we are doing this, we do need to make sure that we graph y equals -2 squared of x first. So it's what we call the parent function of our function. So that's going to be the y equals -2 square root of x. Now notice, once again, we have a -a value. That means we are going to reflect. And because if we take the absolute value of 2, or -2, this will be a vertical stretch. So you can write that if you want to. We will reflect, or it's a reflection, and we have a vertical stretch. Okay, so what we got to do is create our xy table for y equals -2 squared of x. Now, once again, remember, with any square root, we will always use the same 4 points. So the 4 points that we used with our parent function was 0, 1, 4, and 9. So we will always use that. So now we're going to plug that into y equals -2 square root of x. So of course, anytime we multiply by 0, it's just going to be 0. And then when we plug, so -2 square root of 1, that's going to give us -2. -2 square root of 4, that gives us -4. And then -2 square root of 9, that's going to give us -6. Okay? So So let's go ahead and plot those points. We have 0, 0, 1, -2, and then 1, 2, 3, 4, -4, and then 9, 6. Okay. Now, because we are going to be graphing multiple graphs, okay, you will need to create a legend. So knowing that our dot is going to be the parent function, okay, or you can use different colors, that might help as well. And then when we do our straight line, that's going to be our original function. Okay. So now what we have to do is identify, okay, what are the translations? So this is going to be representing your H and K. So remember, H is going to be inside the radical, K is going to be on the outside. And remember, H is the opposite of what you see. Okay, so we see x minus 3. Really, that means we are going to move or translate right 3. And then what happens with our plus 2? That means we're going to translate up 2. Okay, so for each point that we plotted, we're going to move to the right 3 and up 2. So I go over 1, 2, 3, up 1, 2. I go over 1, 2, 3, up 1, 2. Over 1, 2, 3, up 2. And then the last one is kind of a little bit off the graph. There we go. And once again, I draw. There we go. Okay. Okay, now our last thing that we need to do is we got to figure out the domain and range, in this case of the blue. So you're really finding the domain and range of your original function, which in this case is y equals -2 square root of x minus 3 plus 2. Okay. Okay, so domain. So notice we are going downwards, or sorry, for domain, we're actually going to the positive x direction, okay? So our smallest x value is going to be 3. So you're basically looking at your starting point. So it is 3, and since we are going to the positive direction, it's going to go to positive infinity, okay? Okay, now for range. Now notice that's going down. So that means that's going to be our smallest. Notice that our largest, right, y value is 2. So we're going to write -infinity 2. Okay. So you can really look at your x and k values to kind of figure out your domain and range, especially without using the graph. Remember, we can also find domain by setting what's underneath the square root greater than or equal to 0. So we talked about that, right? So we could do x minus 3 is greater than or equal to 0, move the 3 over to get x is greater than 3. So that's another way we can figure out, without looking at the graph, our domain. And then for the range, without looking at the graph, you can basically figure out, okay, with your k value and knowing which way the graph is going to, just kind of in your head, which way is facing, up or down. Okay, and so range is always going to be dependent on if you are reflecting or not and what your k value is. Okay, let's go ahead. I think we have one more. Yes. Okay, I would like you to go ahead and pause the video and try this one on your own. Okay, let's see what you got. So we're going to first graph the parent function. So that's going to be y equals 3 cube root of x. Remember, we use the same 5 points because this is a cube root function. So that's going to be -8, -1, 0, 1, and 8. So I plug that in. So I get -6. I get -3, 0, and then 3 and 6. Okay, we graph that. Okay. make a legend here saying this is my parent function. Okay, so now let's look at our translations here. Our h is inside k here. This is our second part. So since we have x plus 4, that means we are going to go to the left 4. And with our k value of minus 1, that means we're going to go down 1. Okay, so each point that I have, I'm going to go left 4, down 1. So this one, we're going to be kind of off the graph. That's okay. So 1, 2, 3, 4, down 1. There we go. Okay. So now we're going to figure out the domain and range of our blue, so of the original here. Okay. So remember, because this is a cube root, no matter what, the domain and range will always be negative infinity to positive infinity, because we will hit all the x and y values. Okay. Okay, make sure you watch part 3 of this video, because we're going to do a word problem here.